All right. Hello everyone. So this is in this video let's get right on topic. First off, if you want to create a new scene, control N is what you want to press. If you want to create a new node, control A is what you want to press. If you want to create a previously defined scene as a child node, control shift A is what you want to press. If you want to save, control S is what you want to press. One sec. Okay. Yeah, as you can see, control S is what you want to press. If you add some, actually I don't need to bother here, do I? Can use this one. Let's go with this. If you want to move something, W, and then you can drag it around to move. If you want to rotate something, E, you can rotate it from that center special square, cross. You can if you want to scale something, S, you can scale it in X direction, you can scale it in Y direction, or you can scale it in X and Y both using shift and these, basically dragging it in any direction. If you want to open a new scene, open a previously defined scene, control shift O. If you want to open a previously defined script, control alt O. As far as VS Code is concerned, control P, and you can open any script from here. Control S to save, control W to close, control O is another option you can use to open, though I would recommend that if you know the project file name, it is better if you just use control P. That way you can directly type it there, press enter and done. Now before moving on, let's talk a bit about the data types in Godot. Basically what happens is when you want to use some data, when you want to perform some data manipulation to achieve some result, well, you are obviously going to need some data, and there are various ways in which data can be stored and is defined in Godot or in any programming language for that matter, but the general idea remains the same. You have got something called boolean or bool for as its short form, which basically has two values, true and false. You have got something called integer, which is basically whole numbers, positive and negative, along with 0, but without any decimal part. You have got something called float, which is the same as integer but has decimal parts, and you have got something called string. This that I'm going to explain via this example. So as you can see, this line here is sprite, and these three are three more sprites. Imagine if this line represents an entire string, then its individual characters would be represented by these three. Now some of you might not know what a string is, so to put it in simple terms, a string is basically any collection of text or characters. So here in this name of this file, this what do you call it, this node, S is a character and sprite 2d4 entirely is a string. P is a character, R is a character, I is a character, T is a character, E is a character, 2, D and 4, all three are characters. Oh, I almost forgot about the shortcuts, but whether you want to rename a node, whether you want to rename a file, whether you want to rename a folder, whether you want to rename a scene, and whether you want to rename a script, F2 is your key. Now about data types, the basic data types are the basic general classification that I just described. There can be more versions of these. For example, double is similar to float, but it has a lot more precision, as in there is a lot more values after the decimal point when it comes to double as compared to float. Similarly, uint is unsigned int, which is basically integers but only positive values. In Java, there is also this thing called byte, which is basically similar to integers but has a very short range, so can be used if you know you are manipulating only on values in a very short range, with its range being, if I remember correctly, minus 128 to 127. Anyways, so yeah, let's get back to data types. Now these are also called classes. Sometimes they are called blueprints, sometimes they are called templates, sometimes they are called user defined data types. The idea remains the same, and I think it would be better if I show whoops sorry I think it would be better if I showed you here. Now I'm gonna press W. I want you to make sure that you pay close attention to this area of the screen when I move this. As you can see, there are a pair of values, which is basically a pair of coordinates, and they are decimal values, so they are a pair of floats. And it whoops sorry wrong one. Why do I keep I'm an idiot. Anyways, so imagine for a 2D system, a vector 2 is defining their values. So ignoring most of the words that are appearing on your screen right now, so if I were to define and try to define this, it would be something like basically defining a pair of uh, floats that basically come together to form a vector 2. So any value that will be inserted into this would be a pair of floats that would essentially, as you can see here, if we go to its definition, the vectors x component public float x and the vectors y component public float y, along with some predefined constants such as 0, 1, infinity, up, down, right, left. So the idea remains effectively the same, that two primitive data types came together, float and float, and together they are put together in such a way that you can use them as a third data type that is separate from those two, which is vector 2. In this particular case, you can, like, for example, store here something called let's see, here it is, vector. As you can see from the description, it's vector 2 and its position, which is a property that is that denotes the actual vector coordinates of any node basically. In this particular case, since the script named demo sprite is attached to this node called demo sprite. Fuck, sorry about that. So, where was I? Right. So the demo sprite's position is being stored in this. For example, if we were to print it, it would be the value that would be printed would be this. So let's go to, where did it go? Okay, here it is. Let's press F5. Oh, I forgot, but that is another shortcut, I guess. F5 to run, F6 to run the current scene. If you are working in C sharp, Alt and B to compile the project, basically to build it. So it's currently saving it. It will build it up. It will then run it. Well, and once that happens, we should see the value that we mentioned earlier being printed down here. In the meanwhile, while it does that, I would like to talk a bit more about some of the things we are seeing here. Godot, the code that all the code files that are part of the Godot ecosystem, they are basically stored in a you can think of it like a library of sorts. It's not an accurate term to use library here, but I'm not really sure if okay, let's try to explain namespace, which is basically just a collection of various scripts which uh, use and access via this line like this. So stuff like sprite 2D is defined in here inside this namespace called Godot. If this line is not there, then what whoops sorry then as you can see, it's giving an error because the disk could not be found. This contains the definition for this, and by using this we get access to definition for this. It's a way to help keep our code space clutter free, as well as provide additional restrictions to accessing data and thus provide better data security. For Godot projects, we need to using Godot. Using system is not necessary, it's just the default that comes. Public is a word that basically says that any and all files have access to this particular class called demo sprite. You can worry about partial later. Class, I believe I just explained just now, and this basically explains that this demo sprite class inherits from sprite 2D, essentially meaning that demo and then you can add our own on top of it, and it would work properly without us needing to redefine whatever sprite 2D has. Now this seems like it has run. Let's see if we cannot just close it. Whoopsie, hold on. Okay, right. So anyway, so where was I? Right, so let's just close this and let's get here, but the output should still be here. As you can see, its coordinate was demo sprite's coordinate was printed and they were 0 0. So we basically used two predefined data types, float and float, to make a new data type called vector2. Similarly, using three of such data types, we can define a new data type called vector3, and vector3 is used in what do you call it, 3D space for the 3D coordinate system. So yeah, anyways, whoops, where was I? Right. So that is the basic idea behind a new data type. Even complicated seeming data types are at the end the same, using primitive data types such as boolean, float, characters, integers, and using some more user defined data types. Along with those, we basically create new data types, and that's pretty much it. Regardless of how complicated it might seem, at the end of the day, you can always go ahead and check their source code. If you do, you will find that if you keep breaking it down in its simpler what do you call it, in parts of its simpler structure, you will find that no matter what happens, at the end of the day, effectively these data types, a sprite 2D data type is still basically another data type that is just formed using a combination of previously defined data types, whether they were primitive data types or user defined data types. The idea is the same. There is no change in that. So that is what we essentially work with. Any case, ready is a function that is like a blimp in the life cycle of a, what do you call it, of a node. Once the node has been properly initialized, once everything is ready, the ready function is called. When it comes to these nodes, then comes to the node tree, which is how the game essentially structures. This node enters the root tree first, then this, then this, then this, then this, and then when it comes to the ready function, this one's ready function is called first, then this one, then this one, then this one, then this one. That is effectively how it works in this regard, and you can actually see that. Hold on, let me just run it. So once we run it, we should be able to see a remote tab and I believe its name was local tab. Yeah, probably. Anyways, the game is starting, and here we are. So we have a remote tab and a local tab, and as well, it is working a bit slow, but that's besides the point. The idea is the same. When it comes to these nodes, their enter tree and ready function is called in a specific order. The reason why I'm saying this is because if you try to access something from the ready function, something that was defined in the ready function of this node, by using the ready function of this node, then that could essentially be successful because it was defined already in this node, which means it is available for use here. But if you try to do the inverse, which is to say, if you try to use something in this one's ready and that something is defined in this one's ready, so that will not work, and it is something that has tripped me up every now and then, so I sort of wanted to share it. Now just a bit more, let's get rid of this useless lines. Let's see here, we want to define something to access the sprite that we have. So let's define it as, well, we don't need to define it here, we can define it here as well. Let's go for sprite 2D. Let's just give it a name. I'm giving it whatever name I feel is right. Well, there is nothing to be written here, is it? This is the part where I need to work. So this is how you get access to a node. First you need to make sure it's only this particular type. Now and then you need to use the get node function. Here in the angle brackets you define the data type of the node you want to access, because get node normally returns, as you can see, it normally gives back a node. That's pretty much it. So we need to define what kind of data type we want here, and then here we need to define the path to that node. So getting access to the path is pretty easy. Just copy, right click, copy node path, and you can paste it here. Whoops, forgot to put the string quotations here, and there you have it. Now once you have access to it like this, what you have effectively done is we have defined a sprite type variable, and with this we have mapped it to this particular node. I keep opening that, my bad, sorry. So anyways, so where was I? Right. Now we can affect the node via code directly here. For example, we can define its position as, say, I don't know, new vector. This is just how you define a new variable. I don't know. Let's see. And we need to write this because that is part of how you define a float, and that's about it. So once we launch the game, the position should shift from 00 to 300 and 250.0. Let's see if we cannot change a few more properties. Dot modulate equal to color. Wait, I don't really remember exactly how to use the color properties. Whoops, never mind. So let's affect the I don't know, maybe we can worry about other properties later, but anyways, so let's close this. Let's run this. Whoops, sorry. No. Let's run this. And yep, as you can see, compared to what we had here, although this might not be that visible since it's mainly the line that is whose position is being changed compared to this position of the line here. The line's position has changed, and it is the center of the line, center of this image that which that's position is being defined that way. As far as its modulate is concerned, well, this is the property that I was thinking of manipulating, but I need to look up in Google again how do we input color values. I do not remember that right now, but anyways, so yeah, that's more or less about